Hello there, greetings and warm welcome. I am Nebota Ismail and I'm continuing to take us on the application development masterclass, which is powered by the Infinite Web Revolution. So we have started this series. I think we've got 3 videos running. So today what we are going to be looking at is the complete UI development with Flutter. So we have seen the basics like using widgets. We have seen how to use stateful and stateless widgets. So this course is going to be quite lengthy because it's actually going to contain everything you need to know about application development with UI. So that is a Flutter course. Now let's so I have a very powerful textbook here which was developed by us, I think. So it's actually, we are going to be using it as a guide. It was actually made for this course here. So this is the complete UI course. You have everything that you need to know. So let's just take a look. So welcome to the world of Flutter UI development. This course, application development with Flutter, the complete UI design. You will embark on a journey to master the art of creating visually captivating and highly interactive user interfaces for your mobile applications. From understanding the fundamental of building blocks of Flutter UI to exploring advanced techniques like animations, gestures, and state management. This course will equip you with the knowledge and skills to design stunning mobile interfaces that will delight your users. So get ready to unlock the full potential of Flutter UI and take your app development skills to a new height. Now we have continuously seen that Flutter is a very essential tool when it comes to UI design because of its widget-like structure. So Flutter is cross-platform, so it means whatever we build with Flutter, we can customize it for Android, iOS, and now so going to desktop and even web interfaces. So what you are doing here is actually quite advanced because we're actually working with real-life application development. So let's get started. Let's explore the content. So as I was saying again, we are on a complete application development course. This is just a segment of it, so I'll encourage you to visit our past videos. Also I would like you to subscribe so you always get notified whenever we publish new content like this. Now, introduction to Flutter, that is going to be our introductory lesson. So we are going to have a brief overview of Flutter and its UI framework, understanding the basics. Now we are going to go to Flutter layouts, exploring the different types of layouts available in Flutter. We have the row, column, stack, etc. So we are going to explain all of this in depth, and one thing I am very pleased to tell you is you are going to have instructive codes. You are going to have the codes to work with live, so there's no need to bother about anything. Everything is set up for you. Now we are going to be working with alignment, spacing. We are going to be also be seeing styling and theming. Yes, styling and theming is very important. Handling user input and gestures, building interactive UI elements with gesture detector. So we are going to be seeing all of that. Animations, custom widgets to develop your own widget. As we have said, Flutter is a widget-based system, right? So everything in Flutter is a widget. So you want to build a UI component, a button, a screen, whatever it is, it's a widget. So you're going to be learning how to build your own widgets. So creating stateful and stateless widgets, understanding widget composition and inheritance. Now responsive UI design. So yeah, so sometimes you have large devices, you have smaller devices. How are you sure that a layout that goes with my phone also go with yours? That's what we talk about responsive UI. It is one of the bases for UX, for a good UX experience. Yes, for a good UX. So it's often very much important. Handling data and state management. Yes, so we are going to be introducing you to state management concepts. So the primary state management tool we are going to be using is Flutter Riverport, for those who know. So that's just to take us in front a bit, and also working with advanced UI techniques, custom animations and transitions, implementing complex UI gestures and interactions, so exploring advanced UI libraries and packages. So we are going to see all of this. Please, this course is quite elaborate. Everything is gonna be made available, so feel free to follow us to the end. If you need time to rest, you can pause the video, you do what you want to do and continue. Now testing and debugging, very important. Writing a code and you should be able to test it, right? you should be able to test it. Deployment and publishing, you are also going to see how to do that, how to get it running on App Store. So everything you need to know is quite available here for you. So without wasting much time, we are just going to get started now. Looking at module 1, we are introduction to Flutter. Flutter is a powerful cross-platform framework developed by Google for building beautiful and high-performance applications with a single code base. So we have explained so much about Flutter. I encourage you to visit past videos to actually know what we are talking about. Now we have quite a lot seen some advantages of Flutter. Fast rendering engines. Flutter uses Skia, a high-performance graphics engine, to render UI elements, resulting in smooth and responsive user interfaces. So we have spoken about this. The hot reload feature with Flutter. Flutter's hot reload feature, developers can see the changes they make to the UI in real time, speeding up the development process and enabling rapid iteration. So we spoke about the just-in-time compilation and ahead-of-time compilation, right? So Flutter is very let's say efficient when it comes to those aspects. So I encourage you again to visit our past videos. I think this is the second part of this video. Explain that extensively. So we have extensive widget library. Flutter provides a very rich set of pre-built widgets for common UI elements, making it easy to create beautiful and consistent user interface. Now we all know the developers of Flutter definitely cannot actually have everything Flutter has to do inside of it. Why? Because they are humans. They too have limitations when it comes to reasoning. So definitely there are going to be times where you think of something which is not in Flutter's architecture, not in Flutter's installation and everything. So sometimes you might need extensions. So when we talk about libraries now provide additional features to Flutter. We have libraries, we have packages that you can use to extend its features. Yes. So by this, with Flutter, we actually have a vast array of what we can actually do. So widgets are the building blocks of Flutter UI. So we've seen about that. Everything in Flutter is a widget, including the app itself, buttons, text, images, and more. So everything is a widget. So now the widget tree hierarchy. Widgets are organized in a tree structure, with each widget having a parent and 0 or more children. So as we said, that's the hierarchy of Flutter. We have the parent widget, which has the material app as the parent widget. Yes, the parent widget has the material app. The material app, we have a scaffold now, which it just goes down and down. Children. So children, or let's say widgets, compose in this widget tree hierarchical structure to give us our entire application. The top level widget is the root of the widget tree, representing the entire application. Yeah, that's the top level widget. That is a widget which is found on the run app. The run app function, which is the one responsible for rendering your entire application. The run app takes in the parent or the root widget, right? And this root widget must contain your material app if you are working with a material design. Okay, elements and render objects. Elements are an abstraction of widgets and are responsible for managing the state and life cycle of widgets. Yeah, widgets have different elements in it, so depending, remember they have been pre-built. Most of them have been pre-built in as much as you can create custom widgets, but all of these widgets have different elements, different components that actually summarizes it all up. Now render objects handle the rendering and layouts of widgets, translating the widget tree into a visual representation on the screen. Now understand something, the difference between a widget and a function. Okay, as we saw for the past videos, you understand that when we talk about a widget, right, a widget is like a function, but the difference between a widget and a function is that it returns a UI component, right, something you can see. So let's say if you want a button, you simply put it, but it takes in it's going to return to you a UI component. Yes, so in order to get that UI component running, we have elements that are responsible for that. We have render objects. So render objects are responsible for rendering the layout of the widgets. Yes, so responsible for translating the widget tree into a smooth UI representation. That's very interesting. Now we have the declarative UI paradigm. Flutter follows a declarative UI paradigm where the UI is a function of the application state. Yes, that's why you can navigate between different pages. Use things like navigator.push, pop, context, you press buttons. So Flutter follows a declarative UI paradigm where the UI is a function of the application state. So developers describe the UI using widgets and their properties, and any changes to the state automatically triggers UI updates. So we are going to be seeing this extensively while we are working up with the real-time work. Now we have summary and expectations. So in this module, we introduce Flutter as a powerful framework for UI development. We discuss the concepts of widgets, elements, render objects in Flutter UI framework. We have explored the declarative UI paradigm used in Flutter, which simplifies UI development by automatically updating the UI based on the application state. So this has actually been interesting. So now we are going to start up. We are going to start up now. Let's see how to actually, we need to start doing some practice, right? So let's actually see now how to start doing some practice. So firstly, we need to create a new Flutter project using the Flutter command line or an IDE. So that's how you can get your Flutter project running. If you need to know how to install Flutter and use it, there's a video for that. Check out our part 3 of the application development masterclass. You are going to see there. Now so I'm going to be using VS Code. So VS Code, we're going to be using it. So remember, you can also work via the command line. You can work via the command line, but I often use VS Code. The reason I like VS Code is because it is quite simple and it's lightweight, right? It also has let's say extensions package, yeah, where if you install extensions, you can actually do a lot with Flutter. Yes, so this is VS Code. So press Ctrl Shift and P to start a new project. So Ctrl Shift P, let's wait while it loads up. Ctrl Shift P. Okay, that's it. So Flutter project new. So you can also go on with your command line. You use a Flutter create, you put your app name, you open your code editor, and you locate the file. So remember this, whenever you are creating a new project, initially the first time you are going to require let's say you are going to require some data, right? Some internet connection to set it up. So what's happening here? Let's wait for it to actually finish loading. Okay, so yeah, this is it. So it's asking me to choose what do I really want to create. So what I want to create now is actually a Flutter application with descriptive comments and text. Okay, this is just for you for the first time. You would like this, but someone who is not, let's say maybe really you just want an empty application, you are going to get this where you do all of it set up. But since we want an application, we are just going to use this application. It's going to ask you now to locate what type of application you want to open up. So I'm going to just select, I'm just create a new application. I'm just going to say UI master class. At the end of the day, I'm going to share this code on GitHub. UI master class, I'm going to select that. Application name, I'm going to say UI master class. I'm just going to give it that name. So automatically it's going to create the application using the Flutter create command. So let's just give it some time to actually render all of this to us on the screen. So the Flutter UI create command is running. Okay, so it's creating and resolving the dependency. That's why I told you that some internet connection is required. So it has created all of the files. Now it's actually resolving dependencies. So okay, so it has actually completed, and this is our example application now that we have. So this is our main.dat file. It contains a sample application. I will go ahead and since we want to work with UI, I'll go ahead and run this application so that we can actually continue following from it. I'll go ahead and run it on my device. So remember your application, this is the application structure. We have a lib folder, which is the entry point. We are speaking about this. We have our main.dat file, which is where our main function is found. The main.dat is where the main function is found, and it contains a specific function here called run app. What is run app? Run app is the function that is capable of rendering our entire UI screen to us. So this is actually what is supposed to render our entire UI to us. So whenever your application runs, the main.dat file is brought into play, the run app function is executed, and you actually have access to all of this. Now the first thing I'll do is I'll need to migrate onto this particular file where we have the UI master class, and I'm going to say that cd UI master class. It's just a command. Let's see what's happening. UI master class. Okay, it's okay. I'm already inside of it. Okay, I'm already inside of it. Okay, I'm already inside of it. Okay, so while this is setting up, I would like to first of all set up GitHub, right? Let me show you how you can initialize GitHub on your project. Let me see how. No, we are going to have a separate video on that. Let me know confuse us now. Let's just give time for Flutter to run. Okay, so so open the main.dat file and locate the build method of the my app widget. Modify the UI by adding a container widget as a root widget of the build method. Inside the container, add a text with a custom message of your choice. Run the Flutter app and observe the changes. So let's just give some time for application to set up correctly, because usually for me, if it's not properly set up like these things, no more turning again, then it might disturb me while working. So let's just give it some time. Okay, I think by now it should be finished. Okay, I'll go ahead and run the application so that we can actually see it. I have my phone connected. Make sure that your device shows this. Okay, make sure your device shows this. Also, there is a very good tool I have here with me. We call it SCRCPY, right? What's the purpose? It's actually to get your device running like you see it like this. So for those of you who have never been into application development, here is how you configure your phone for USB debugging, right? Here's how you configure your phone for USB debugging. First of all, you go onto your settings. You locate about phone. look at something. Initially you see here developer options, right? This is because I am already a developer. What that means is my phone can be used for Android development. But if you are not gonna see it. Some people have different places where it is found, right? But in order to enable it, initially your phone doesn't have it turned on. So you go to about phone, you locate build version of your phone. This one already developer mode. If not, just keep on tapping on it like multiple times like this. Just keep on tapping it, and when you tap it for long, they are going to tell you 3 steps away from being a developer, 2 steps away, and at the end of the day they are going to now ask you to input your pin code. You input it, now you are going to be a developer. So when you're on your machine, they are going to, when you plug your phone via your USB cable, there's going to be a message popped up on your screen telling you that, do you want to connect this? They are going to display a certain message like that. You enable it, right? Enable it, so your phone now will be detected here as an emulator device. This is only possible if you have set up your Android development on your machine, on your laptop or computer, whatever. So that's the first process. So enable debugging, since we are starting with development, so you need to have that set up. So while I'll be doing all of the coding, I'll definitely have this here. Okay, so I'll just have this here like that, so that we'll be able to test and debug whatever we are going to be doing. So the first thing I'll do is to run the application so that we can actually see it on my phone. So I'll look at run, and run without debugging. Okay, so Flutter launching. So please, the first time you want to launch your application, make sure that you have internet connection. If not, it's not gonna work. This is just the first time, but after you've run it, you can keep on developing without using an internet connection. But the first time it needs to connect to the internet, get certain dependencies before it can run properly. Now if you notice, launching lib/min.dat on SMDs. You can also launch on Chrome, right? If you don't actually have an Android device, you can launch on Chrome, but you are going to be viewing the web-based version of the application. But it's still good for those of you whose devices cannot connect, or if you don't have an Android device for the meantime. If you are working on iOS, the same thing, you connect, but know that this training is specifically for Android development. So what that means is there are going to be some fine-tunes needed in order to connect iOS devices. Since we are not really using an iOS device, it's going to be a bit difficult. So here are the tricks that could work for in order to get it fine. You either get an emulator like when we're doing with Android development. So you go to our Android Studio. When you launch your Flutter project, you are going to see device manager, right? On device manager, you now enable you now enable your emulators. So okay, so right now let me look at. So we are still waiting on Flutter to launch, so I'm going to pause the video a bit. When it comes on, then we are going to continue. Okay, it says parameter format not correct. Okay, it's coming, it's launching. The first time it always takes time, and make sure you have space on your phone, right, up to maybe about a gig, because this is a debug version of the application coming into your phone. So what that means is you are going to be seeing it here like an application. Actually, you are going to be seeing it with a Flutter sign, but with the name of the application. So you need to have some space. Initially it comes at about 300 megabytes. While you keep on adding stuff, it could go right up to 500 megabytes, 600 megabytes. This is just the setup, the debug version. It has all of the chunk and everything. That's why it's of that length. But when you build the application like an APK, it's not going to be that way. Okay, so right now just follow, and please try to keep some space. The reason why using an emulator on your device is not really the best is because when you use an emulator from your device, what happens is it actually kills the performance. Your machine becomes so heavy, right? So that's why you notice if someone will use Android Studio for development using Flutter, you can use it. You are going to always notice that your device is going to become slow, getting heat up, and some other things like that. So let's continue. Okay, it says build app slash outputs slash flutter apk app debug.apk. Okay, so it's actually building. Very soon we are going to be seeing it on our device. If this shows different, okay, that's it, that's running, that's it, that's running. So if you notice it, it's actually building up. Okay, open up inspector tools. Yes, it's fine now. So let's just give it, wow, impressive. So that is the first UI you are ever going to see when you just start up an initial Flutter project. So congratulations, this is just your first application. You can see here what is the purpose of this application. If you click on this button, what happens? You increment. If you notice, Flutter has gives, now it is connected to debug mode. You actually see processes happening behind the scene, so you can actually see them happening. So congrats. So let's take a look at how the application is stored. If you go now here, you locate we have the app name is UI something, so you are going to see around UI master class. So this is it. So this is what is running. It's now running like an application. The first thing I would like to do is to remove that debug from up there. So I'm going to check on the app, what they call debug show checker banner on your material app. I will set it to false. So the material app, so debug show checker banner means you are on debugging, right? So I've set it to false, and what can you see now? Immediately it has gone off. This is what we call hot reloading. Automatically it has wiped off the screen just by saving. So this is the concept I was explaining. What is happening is, as this application has built this screen here, what happens? The application has been converted to an intermediate code, right? It has been converted to an intermediate code. So changes you make does not necessarily need to build the entire application again. It just needs to render what you have changed, add it to the intermediate code, and render it for you and display it for you. So that is what makes it extremely fast. Now look at up there, the title says we have class homepage. I'm going to see how to, we are going to remove all of this off the screen because this is not our initial project, since you have never seen this. So I'm not even going to disturb you on that. So I just want to show you the title, how we can change it. Okay, they say my page title Flutter demo homepage. So I'm going to write here UI masterclass, and I'm going to save it. Yes, so you've seen how it has changed immediately directly from our application. The hot reload feature of Flutter is powerful. Okay, so the first thing I'm going to do from now here is first of all, I'm going to delete this home page. I'm going to delete this home page and all of its code that comes. So remember, in Flutter, everything, we first of all have our main function here, which is supposed to be inside of our main app. We have this. So the first thing I'm going to do is I'm going to clear our entire screen. Because in order to do anything, we need our main function, right? In order to do anything, we need our main function. So I'm going to say void main. So void main. So we are going to have run app. Run app now needs an application, which is a UI. So if you can see here, it says widget UI. So it needs a widget app. So inflate the given widget and attach it to the screen. So that's what's supposed to do. Since we don't have any widget now to do, we have to implement our base widget. So I'm going to just call it UI master. I'm just going to call it UI master. So I'm going to first of all create a state. I want it to be a stateful widget. So whenever I want to create a stateful widget, if your thing is set up, I'll just go STF. It's just going to show me stateful here. So I'm just going to say stateful widget. So it has created it. I'm going to give it a name, UI master. So that will be the name of this particular widget. Now it's supposed to return a material app since it's a first and the base widget. So I'm going to return a material app. The material app is now supposed to have a property in it, the property called the home. So the first initial widget is, or let's say your root widget is always containing the material app, right? The material app is your parent widget. Now under your material app, you have now what we call a home property. The home property. What is the home property? The home property now renders the screen, the initial screen, to you. So whenever you want to create a screen like this one, what is a screen called? A screen is called a scaffold. Whenever you want to create a screen, it is called a scaffold. So I will just let it be this way, and I'll re-render the application. Okay, cannot re-render because it's an error here. So this run app needs an application. We are just going to now pass it our UI master. So it's going to take the UI master. So it asks me for const. So I'm going to enable it. Okay. So I'm going to save it now. Automatically the whole widget has built. So you can see it displays an error. The reason is because everything has changed. So we need now to rebuild this application. We need to rebuild this application. I'm sure we'll need to rebuild it like from crash. So I need to okay. Application restarted. Okay, now this one too, I need to remove the banner, the debug banner check, whatever it is. I'm going to set it to false. So I'm going to remove the debug. So now application is empty, nothing is there. So this is what a scaffold is. It actually presents to you just this white screen. As you see it like that, it's just white. So you can now place contents anywhere, everywhere. So that's actually interesting. Congratulations, congrats. So now I'm going to go ahead now. We are going to follow our course syllabus so that we can now understand everything that the UI has for us. So the first thing that was said here is modify the UI by adding a container widget as the root widget of your build method, as the root widget. So now let's check the root widget. Let's add a container and see what happens. This is the root widget, right? So let me add a container. Please, we are seeing stateful and stateless widget, so that's why it's no longer too much in, let's see, so we are no longer speaking too much about it again. So have you seen, if you do it like this, it just shows black like that. It's not actually a screen. So it just shows black. And let me see, I put a child there. The container is what we call a child. I'm gonna put a text. I'm gonna put a text there, and I'm just okay. Let me just call it data like that. Look at what happens. No directional widget found. Rich text widgets require a directionality widget and all of that. So it cannot render. Why? Because we need a scaffold. We need to have our screen set up. Also, we need a material app. The material app is where these widgets can lay on. So I'm going to copy this widget. I'm going to cut it. Then I'm going to restore the material app. So now let's see, now in place of in the home where we have a scaffold, now let's see what happens if we instead place the container there. This isn't a constant constructor. We're going to remove the const value here. Let's see something. Wow, interesting. So you see, it's not actually a page. So now the material app is there, which can contain elements, but we need a context. We need actually a context to deal with. We need a page. Yes, so we have a build context here, but we have no context, so we need actually a page. That's why the scaffold is always your parent. Sorry, after the material app, the scaffold is what now holds data. So inside of the scaffold, we have what we call the body, and inside of the body, now we are going to have our container. So remove this const here, and let's see now what happens. Okay, it is fine, it is fine. But look at what data appeared. Data appeared right up. How do we adjust this? We have what we call a safe area, right? So our scaffold basically covers the whole screen, But a safe area, we have a widget called safe area widget. What is a safe area widget? It enables, or let's say it disables, the ability of your app to actually extend this bar. So what happens is it's gonna keep all of your application from interfering with all of the safe areas of your application, like the portion of your screen that your phone actually uses is going to try as much as possible not to interfere with it. So I'm going to refactor this. I'm going to wrap it with a widget, so I'm going to call it safe area widget. So if you notice, it's just going to refactor, or you can just manually do it. So when you do that, notice what happens, it has actually left there. So have you seen the powers behind debugging? If you notice it here, it gives you all of the errors that are popped up while your application is running. The next thing is, let me put this on a center. This text widget, I want it to be centralized, so I'm going to refactor it to be centralized. If you notice, it is, wow, that's it. So that was just a test. Okay, so run the Flutter app and observe the UI changes. Okay, now let's look at Flutter layout. So Flutter provides a variety of layouts that help in arranging and positioning widgets within the user interface. So some commonly used layouts, we have row, column, stack. So I think we saw about this the last class or last two classes. The row is a layout widget that arranges its children along a horizontal axis. So the children are actually along a horizontal axis. Children widgets are laid out horizontally in order they were added, in the order in which they were added. Use the main axis alignment property to control the alignment of the children along the main axis. So the row widget has children. The children now are going to be aligned horizontally. So now we have what we call the main axis alignment. The main axis alignment specifies how they are going to be aligned internally. So are they going to be choked up together? Are they going to have space between them? That is what it says. So now let's look at an example code that that implements this. So I'll just copy this because I don't want to take out much time of the code. So okay, now let me just do it since it's a bit short. So we are going to remove this data that is here. So in place of this container, I'm going to have a row widget. No, let me let the center be. Okay, so we have the center inside here. I'm going to input. This is how you build widget trees. So we have a container, it has a child which is a center widget. The center widget just means everything under it should be at the center of the screen. So the center too has a child, that's all told. Everything has a this child as it goes down. So now we have this. Now we should have here a row widget. I've gone and emptied even this side. Okay, so we have a row widget here. So now the row widget takes in what we call children. So the children are simply going to be these text widgets. I'm just gonna take them from here because I don't want to type too much. So text widgets, so we are just going to put them there. So we have text, we have the data that is inside of the widget, we have text widget 3. Now so we are going to now set the alignment. Okay, and before we actually set the alignment, let's run it. So if you see, look at the way they have actually aligned to each other. Now my code constantly gives me tips on how to actually improve my code. That's what they talk to me about, using const. So I'm just going to refactor based on what they are saying, but it's not a must. So they just say add const everywhere to show there's a constant widget, does not change. Okay, so the widgets are applied like this. Now you may not always want it to be like this while working, so that's why we are speaking about what we call main axis alignment. Main axis alignment now specifies how they are going to be aligned on the screen. So we are first going to start with center. Main axis alignment dot center. So the main axis alignment dot center centralizes all of the widgets, right? So let's try space around and see what is going to happen. Wow, that's good, right? So you actually give space around them so you cannot touch these walls. So now we have space between. Wow, you see it actually touches the wall. It's actually giving out small space between them. Now you have space evenly. We have space evenly. Okay, so space evenly just gives them equal space. This is the best I like. This is the best I like, space evenly. So if you notice now, those widgets are arranged. How cool is that? It's actually very good. Yes, so that's how you work with rows. So that's how you can align content. So whenever you are going through any web page, any website, oh, before I forget, by the end of this video, we are going to be looking at how to develop these various UI screens that we see actually in front of us here. This one, I have the images, don't bother. So we are going to see how to develop each and every one of them. That is quite interesting. So this is actually supposed to give you all the knowledge you need when it comes to UI development. So as I said, please, if you have something to do, you can pause the video, do it, because this video is quite gonna be a little bit long to go on with. Okay, so now we have the column layout. The column layout is a layout widget that arranges its children vertically. Children widgets are laid out vertically in the order they were added, right? So it's just the opposite of a column or of a row. It actually arranges now the children vertically. So now the only thing I'll do is I'm just gonna change this from column, from row to column. So it's actually the same, all of the other aspects. So I'll just say column. Okay, so I've set it to a column, and let's see now how it comes. So you see, main axis alignment dot space evenly, set it up that way. If I say space between, see how it comes, it goes like that. If I say space even, space around, see what happens. If I say center, see what happens. It come like that. So we just let it be that way. So that's interesting. That's how you work with the column. I like this because we're actually looking at them visually. Now a stack is a very important widget to look at. So stack is a layout widget that allows widgets to be stacked on top of each other. Remember the term layout widgets. So stack is a layout widget that allows widgets to be stacked on top of each other. Widgets are positioned using the positioned widget or by setting the top, bottom, left, and right properties. Now, this is an example code. Now, if you want to work with a stack, what is a stack? A stack enables you to actually add up different elements on top of each other. Let's say you go to let's say you look at a UI screen, you see an image behind. At the top left you see a button, at the top right you see something else, things like that. Or let's say, for example, even this our screen that we are actually looking at now, there is actually something behind which actually scrolls, but it appears as though this one is on top. So if I click on this, I'm not actually clicking on what is down. So this one is stacked on top of this one. So what is a stack? A stack adds UI elements on top of each other, So if you notice this, if you have done data structure, so a stack, the last in is first out, so that's it. So let's see an example of what a stack is all about. So a stack is defined the same as column, row. So stack doesn't set them horizontally, doesn't set them vertically, but you can decide to set it up the way that you want. Now there are ways of actually now positioning elements within a stack. Remember, you can place it anywhere, but if you want to position elements within a stack, you either use a positioned widget as a child. For example, while we have the stack, we have children, use a positioned and use a top, left, right, whatever property that you want to use. Or you can still use, okay, for example, a container, you can define setting alignment with a container. Okay, so let's just see an example now. I'm just gonna copy this code. Okay, so let's see now how stack functions. So I'm going to remove going to take away this color container. No, I like the center widget. I don't want to take away the center widget. Okay, that's how Flutter is. A simple stuff like that can actually make your entire code not run. What is happening again? Okay, there's a little error at the bottom, as I can see here. Expected this. Okay, let's try to debug that. Okay, there is no ending brace. Okay, it has been fixed. Okay, you can see what the stack does. It actually, now we have this red box behind. So we have the we have a stack, the children. The first one, we have a container which has colors.red. It has width 100, it has height 100. So this is this big one with red. Now we have a positioned keyword. We have the position. The position means we want to actually position it. If you notice, it is not actually at the center, right? So let's say the position, let's say the top is 10. Yes, I will say top is 10. So it means it's going to just be 10 inches away from the top, right? So the left giving that one, then we have now the child, which is a container which they are put it blue and the width, height and everything. So rendering that, you see it has gone to the top. You can also set it to the bottom. You can decide on how you want to put it. You can also use what they call an alignment widget. What does an alignment widget do? It aligns the widget to the desired location as you want it. We have top left, top right. Even a container has the property. Let's look at there's an alignment property of it. Okay, there's an alignment property of a container. So let's look at it. So we go on to alignment. So let's see how to align this. So if I say alignment, it's going to give us multiple alignment properties. You can give your own. So we have, I'm going to say alignment dot bottom center. Let's look at how that is going to be. Okay, so it has not actually really changed because there's actually no defined dimensions for it right now. But if we put this in something like a box, it's gonna be that way. But okay, that's just how we do. So in due time, I think we are going to look at practical examples to see how to use the alignment. So that's about a stack. Now, constraints and sizing. Widgets in Flutter are sized based on the constraints posed down from the parent widget. Widget can have a minimum and maximum size based on these constraints. Now use the expanded widget to make a widget take up all the space within its parent constraint. Now whenever you have these particular three widgets, a row, please take note of this. If you are watching this video, take note of this. Whenever we have a row, you have a column or a stack, placing elements there is often very dangerous. Why? Because along the usage, right, there are times where the elements can get bigger than your screen available. Let's say you place a box here which is maybe of size 200. You want to place another one here, and you want to place another one here. There are possibilities that's going to go off this screen. So let's just see this one. We have the width here 100. Let me send it to 1000 and see what happens. Oh, it actually went. Let me set it to 4000. Okay, it's actually going. Not giving an error now. Okay, it's not really giving an error, but There are times where you are going to see an error. It's not really giving an error now. I think the container widget is the one which is find that. But there are times where you are going to have a definite error. You are going to see it. You're going to see it so many times. So what happens is whenever you are inside of this, whenever you want to, for example, right now we are inside of a stack. It says unnecessary container present here. Let me remove this container. So always try to put these elements inside of what we call an expanded widget. Inside of what we call an expanded widget. What is an expanded widget? Let me see something. List. Okay, no, let me not. So we are going to see it when the time comes. What is an expanded widget? An expanded widget is a widget that automatically adjusts its size based on this other one. It's like a flex when you're dealing with HTML, CSS, right? So right now, just working with these guys, there are times where the screen content may actually be larger and you actually pose an error. So what is going to happen? You use what we call expanded widgets to actually fit it on the screen. So we have a row, we have an expanded widget, then we have a child. You now put it the container. We have also another child again. Okay, now let's see this particular example, and we are going to remove the expanded widget and see what happens. So I'm going to come up here. We have the stack, we have children. Let me just add it there as a step child. So we are going to have this down there. So I'll add this. So you see, actually it's good, it's great. So now let me remove this expanded widget from here. Remove this widget, remove this expanded widget. Okay. Where's actually the row widget? Width 2000. Okay, this is exactly what I wanted. So have you seen what has happened? Right, overflowed by this. It can actually give you bunch of errors telling you this, and sometimes when newbies, you just see this, you just tend to lose courage, because this, I'm telling you, this can harm your experience. Okay, sometimes you build something very good, but making it fit on the screen dynamically becomes very difficult. Yes, so right now the thing is, this width is 2000 and the screen is not up to that size. So what happens? It has given an error, but immediately I put this inside of an expanded widget. What happens? It automatically takes the size of the screen which is available. So I'm going to set it to let me see, I put it inside of an expanded. So both of them are going to now actually just take the size of they are just going to take the size of their parents. Since I've actually just giving it, I'm not sure. Okay, you have seen now, even though the width is 2000, but it has actually just adjusted. So that is how we work it up. Okay, so that is how we work it up. Very good. Now let's take a look at something else. Now, alignment and spacing. Flutter provides properties like main axis alignment, cross axis alignment, and main axis size to control alignment and spacing within layouts. So we have said there are three basic form of layouts that you should know of. We have the column, we have the row, and we have the stack. So inside of these three, we have what we call the main axis alignment, the cross axis alignment, and we have the main axis size and the cross axis size. So what is main axis alignment? Main axis alignment is how it's supposed to align on its main axis. So okay, this is, I'm going to go ahead, I'm going to remove these other components. This top and stuff, and I'm just going to allow the row inside here so that we can actually visually see its implementation. Okay, that's it. So now what am I going to do? I'm going to set this thing. Let me remove these expanded widgets. Let me remove these expanded widgets so we can see how to control them. With those expanded widgets there, they are just going to automatically scale up. So let me also remove this. If you want to comment out something, you put 2 lines in front. So okay, so we have not given any width. Now let's give, let me say, width 20 or 200 and see something. Okay, so that one has width 200. This one has no width, that's why it has not shown. So I'm also going to give this width 100. Okay, so it has added like that. Now let's add something. Let's look at in fact, since we have come here, I want to take off this stack so that the stack should no longer disturb. Remove this widget. Okay, so it's now, we are just now left to this. Okay, now I'm going to go ahead now, and now what is the main axis of a row? The main axis of a row is actually the horizontal portion. So it means that if we say dot center, it's actually controlling how horizontally it is aligned. But when we say cross axis, it's actually the opposite of the main axis. So for a row, the cross axis is this vertical direction. When we are on a column, the main axis is this. So whatever changes you are doing on the main axis alignment, it affects this. Cross axis now becomes this other side. So if I say cross axis alignment for a row, what I'm doing is I'm controlling its spacing on this screen. So let's see it. Cross axis alignment should be equal to cross axis alignment dot end. Look at what that means. Okay, it's not going to show because we have a center here which just wants to centralize everything. So I've removed the center and see what happens. Okay, so dot end. So you see it has taken it to the end here. So if I now say that dot start, let's see, is dot start really going to have effect? Okay, still the same thing. But anyways, we are going to be looking at more practical example. So that's how it is. So that's a cross axis alignment, whereas the main axis alignment now, the main axis alignment is now going to say how it should be. So dot space evenly, or let me just say dot center. Wow, so that's it. It centralizes on the screen. So that's how we work with that. Okay, so these are two things you are going to be encountering a lot. Cross axis alignment dot center, main axis alignment dot this. You are going to be seeing that a lot. So summary, Flutter provides different types of layouts like row, column, and stack for arranging and positioning elements. Constraints passed down from the parent widget affect the sizing and positioning of child widgets. Very important to take note of. If you have constraints which were primarily set up, let's say by certain parent widgets. Okay, so alignment and spacing within layouts can be controlled using properties like main axis alignment, cross axis alignment, and main axis size. Now let's look at a hands-on exercise. Let's create a screen layout using row, column, and widget. Follow the instructions. Create a Flutter project. We already have one. Open the main.dat file and locate the build method of the my app widget. So we are not using this one. So inside we just want to actually input all of these things. So let's see. Okay, I'll just go ahead and copy all of these, and it's gonna review the entire widget. But it's the same thing. Let's just copy this. Okay, just copy. I'm going to end here so that we can actually see what this is all about. Or in fact, let's just create an example. Let's just create another widget. Let me just show you how to do this. I'm going to go to new file. I'm going to call it I'm going to say layout .dat. So what I'm doing is I want to build the page that we are working with over here, right? So I'm going to call it layout.dat. I'll paste the code. Let me complete it. Okay. Okay, so that's a complete code. Okay, this is the complete code. Let me refactor it. Okay, the first thing is I'm gonna have to remove the void main from here, since the main must only be found in inside of the main.dat file. So I'm going to remove that. So okay, so I have this. Let me look at if there's any error. There's no error, no changes have been made. Okay, it's fine. So now we want to build this widget. Let's look at what this widget actually contains. It actually contains a material app. No, we don't want a material app. So we're going to remove the material app, scaffold. We don't want all of this. We just want this scaffold. We don't want the material app, because the material app is supposed to be used just once. So I'm going to cut this off the screen and take away the material app. Okay. So I will change this again to layouts, so that layouts, that's a class name. Okay, so now inside of our material app here, where we have this safe area, the child, now here we are going to this is where we are going to be testing all of our widgets that we are going to be doing. We are just going to now call on the layout widgets, layout widgets that we just build now. So layout, if you notice it, automatically the package has been imported. So import package UI master class layouts.dat. So the class has been imported. So that's a child from our safe area. Oh, our application has been disconnected from the device. That's why I could not get real changes. Okay, let me just rerun it so that we can get it back on. Okay, so it's running. It has actually closed the one that was running, and I think he wants to rebuild it. So remember, you see, the first time it actually was doing it actually took a longer time, but right now it's no more taking a long time again. That's because it already has it rendered, so you just need now to just do some few changes. Okay, good. This is actually a very good example. Let's take a look at its architecture. Now, since the body, we have a home, we have a material app. The home now takes a scaffold. The scaffold now has a body which takes in a safe area widgets, which takes in layout. Layout is a class which returns, is a class which is actually from a stateless widget. We have seen how all of this work. A stateless widget. Now let's explain the architecture. First of all, we have a scaffold which actually has an app bar. The app bar has a title which says layout example. So the title is a text widget. On our previous video, we actually saw about the scaffold mini properties. Now we have the center widget, which actually makes everything here in the center. We have a column. It has a main axis alignment dot center. So everything here, that's why everything appears to be in a center. So it means inside of our center we have our column which has main axis alignment dot center. Then now we have children. The first child is welcome to the layouts example, which this is it. Now the second one, we have a sized box. The sized box height 20. Sized box is just a widget that is used to give spaces. You can just create it and give it defined direction. So if I put width, it's going to have a specific width, and nothing can be in that space, so it's just like free space. So if I talk about a size box with a height of 20, it just gives you this space between this and this. Since we had everything to be centralized, now let's take a look. If I remove this size box, see what happens. That space is lost, right? So that's why the size box is there. It's just to give that space. So I'm going to let it be that way. Okay, so now we have a row. The row, this is why we need a row. Now we need to place these 3 objects in a row like this, in this format, but Flutter has no direct way of putting this other than using a row. Now, remember, there are other ways you can go around it, but the row is the best. So the row now takes this one, places them horizontally. So inside of the row we have the main axis alignment dot space evenly. Now we have children, we have 3 containers with a custom height and width with their custom colors. So you have seen that is what makes it now, gives it now this way. Now we have a size box which is given this space. Then we have a stack which now has this yellow and text on top. So if you want to design something which has a background text on top, that will definitely be in a stack. So you have seen how the stack works. This one you cannot add text directly on top. Why? Because this is not a stack. Remember, all of these things are inside of a column. That is why they can appear in this format. Yes, so initially if you want these elements to be able to appear in this format, you need a column. That's what happened. That's why we needed a column. The column has 3 children. The first one is a text widget, the second one is a row, and the third one is another is a container, which is actually a stack. Yes, so this is how you actually work with UI. So the text widget has style. Anyways, we are going to get into styling so you understand. As of now, the styling is not more important, it's just how you can put these things. So that's how you actually create visually appealing UI. So we are going to continue up and see more advanced ways of doing this. Now run the code and look at it. Okay, styling and theming now. So here we have to explain now how we can actually style the different components of our pages, right? Now Flutter provides built-in styles and themes that allow developers to create visually consistent and appealing UI interfaces. Now, first of all, built-in styles. Flutter provides default styles for various UI elements such as buttons, text, and containers, right? Now these styles can be accessed using the theme.ofContext method and the appropriate style class such as button style, text style, container style. Now let's take an example like this. When we had this text, we had what we call a style, which now the style is a property which now takes in what we call a text style. The text style now has what we call a font size, it has what we call font weight, which now made it to be let's see, have weight like this. Notice, look at the difference between this text and this text. This one is just normal. This one has what we call a style. It has been given a certain font size and font weight. Now look at this as an example code on now how to actually work with. It's an example code on actually how to work with style. So first of all, we are using a button. So this is how you create a button. We want to just create a button with actually style that actually is going to show something or be visible to us. Now look at, we have elevated button, right? Elevated button is a form of button. We have elevated button, we have material button, so you can use any one. So we have the style. The style now defines its visual appearance, right? So we have the style takes in a specific constructor called the button style. The button style has a background color. Please, these things are standard, always follow them. For example, if you want an elevated button, you have it has a specific property called a style. Now the style, you define the style by the button style method. So I have the button style now, which has background color, which will say material state property dot all colors dot blue, right? We have the text style now. which is actually says how the text inside of it should be. It takes a material stored property dot all text style. The text style now has colors.white. So what does this mean? The material state property has already been designed by Flutter. It's just left for us to use. So what you are saying is material state property dot all. So you are saying actually all of it's supposed to be blue color. You can try to modify it. Maybe when you have time, you try to check. Maybe you can give it gradient, whatever it is. The text style refers now to how the text inside is going to be. So let's just copy this example code and run it to actually see how it's gonna be. So I'll just put it down here at the end of this layout and render that. Okay. Oh, it's actually inside of, it's actually on top of the, it's actually on top of the stack. So okay, let me get out of the stack and do it. What's on top of the stack? Okay, so that's it. So I'm putting it under the row. So if you can see here, we have this is a button, pressable, clickable. So this is how you create a button in Flutter, right? Very simple. That's how you create a button. So if you come here, we have an elevated button. These are the properties which are there. We have the onPress. The onPress specified what happens when we press the button. Let me just add a little logic here. We have onPress. I just want it to print a number when I click on it. So I'm just going to say print hello. I'm just going to say this. So print hello. So whenever I click on that particular button, it's going to print hello down here to my console. So on press hello, you have seen it there. So that's it. So that's why you define your logic now. So the elevated button has an onPress. So this is what happens when you go to an application, you press a button, something happens. So that's how simple it is to do with Flutter. Now since we have pressed, we can actually see now what happens. We also have the child, which is a text inside, so all of the text. Now our aim is the style. Now we have the style. We have now look at something. The style takes a button style. This one has been predetermined by Flutter, right? It takes a button style. Now the button style now has many properties. We have the text style, we have the background style, we have the foreground style, we have the overlay color, shadow color, surface tint color, elevation. An elevated button, if you check this button, you can actually feel like it's floating, right? That's what we call overlay. So the button style, now there are many properties. So the most important, first of all, we have the background color, which we say material state property. Now when you look over this, we look at the background color. The background color, let's say by here, we have text style. The text style says material state property. It means the property is a material state property. That's why we have what we call a material state property dot all. This one has been predetermined by Flutter. You have no choice but to just learn it as the way you have seen it. That's how you style a button, right? That's how you take it. The text style, they have told you how the text style should be. The style for a button's text widget descendant. Now you have seen how it's supposed to be, right? It's supposed to be material state property dot, we have material property dot all. We have now inside of here we have a text style which now has a colors dot white. So let me change this to green and see what happens. So green, wow, good, that's good. So you can actually see how to work, right? So if you are building an application, I'm sure by now you should be able to get some things done. That's interesting. Okay, so that's just the first. Now customizing styles with theme. Customizing style with theme. Now the first thing you notice is these are custom styles. So while we are working inside of our application, right now, for example, we have decided to give this button its own style. There are times where, let's say you go to a certain application and you notice that all of the buttons have the same color, all of the text have the same color. Certain things are just the same throughout and consistent all over the application. They use a particular font, their buttons have a particular shape, a particular color, the way they are. This is what we call theme. So if you are into maybe design and whatsoever, so a theme is just like actually the pattern to which all of these things come, the form in which all of them come. Look at all of the text that is here. All of the text, they are of the same font. So what if this one were capital letters, some of them were small letters? So we need a particular pattern. That's what a theme is. So the theme can also be customized. So if you want to customize a theme, what is happening, you are setting up general parameters that apply throughout your program. So Flutter's theme class allows developers to customize the default styles and create a consistent visual theme across the entire application. So if you want to set certain colors, most applications, let's say you are running an application, and remember, every application needs a specific scheme of coloring, right? So if your primary color is blue, some people might have primary color red. Now if you notice it, initially Flutter's primary color is blue. Yes, that's Flutter's primary color, but you can go ahead and customize this. So if you want maybe red, if you want green, you now set it a way that most of your elements by default come with this particular color that you have set. So now the theme widget is typically placed at the root of the widget tree, and all descendant widgets can access theme using theme.context. Remember, what happens is the material app is the root, right? So if you place the theme at the material app, all of its children are going to inherit it. And how do you access it? You use theme.context. The context now is the context of your application. So developers can customize various aspects of the theme, such as colors, font, and shapes. Please, before we continue, this particular textbook, if you want access to it, it is paid course. It's actually paid. I think it's about 5,000 francs. You can pay for that and you can get it. Okay, so we have material app. Okay, so this is setting up the theme. Now let's first of all look at, we have a material app, then we have theme. The theme takes in what we call a theme data. We have the primary color, colors.blue, accent color, colors.orange, text theme takes in what we call body text. So we have body text 2, headline 1. So these are the different properties. So let's look at let's go to our main.dat. Let's look at the material app. Let's look at theme. So we have theme. So now the theme takes in what we call theme data. Now let's look at here. These are the different stuff that you can apply to your theme data, right? You can use many stuff. You can change it depending on what you want. There are so many properties here that you can change. If you notice here, you can actually see so many of them. So let's just take examples of what is here. So now first of all, we have the primary color, which is colors.blue, which is Flutter's default color. So let's look at something. So we have primary color. Let's just say colors.red. Let me just say colors start with capital letter. Let me just write red, so that automatically it doesn't want to show. Colors.red. Yes. So let's look at something. Now look at that particular okay, it has not changed. It has not changed. Anyway, we are going to change it. So right now this one cannot, because the primary color of this particular layout just came like that. Or in fact, just look at even this this background color. Let's remove the style. From this button. And take a look at its default style. It's blue. Yes, its default style is blue. Let's say an exception was shown. Render overflow object. A render overflow object, it means this thing wants to overflow. Now this, you are going to be seeing this a lot, this particular error. Now what is happening, this screen has a definite size. So what that means is, if the content of the column gets too much, it's going to cause errors. So we have what we call, we need to make our page scrollable. We have what we call a single child scroll view. Single child scroll view. We are going to wrap our body inside of this. So what is its purpose? It's supposed to make now this page scrollable, right? Yes, so our page now becomes scrollable. So if you notice, if I do like this, if I try to do like this, you are going to see it. Why is it not disposed? Let me rebuild my widget. Okay, so that's it. Now where were we were looking at, okay, theming. Okay, theming. Now we have actually built the theme. We have actually added theme data, primary color, colors.red. That's the only. So there are many of them that you can add. Accent color, texting. Please feel free to make changes to this. My aim here is just to actually get you to know the different theme, the different aspects. Now let's go to our scaffold. Let's go to this scaffold here. Let's go to this scaffold, right? Now let's try to change the app bar from here. Let's try to change the app bar from here. So I'm going to say we are going to come up to app bar. We are going to now see let me just see. Okay, let me see what options are available here. Background color, whatever, primary true. Anyways, let's just look at the app bar. So we are going to see background color. No, background color. So now what is going to be the background color? I want to actually make the background color of this particular app bar to be that of the theme. So what am I going to do? I'm going to say theme dot of context, as you saw, dot primary color, and boom, it's going to go. It was red, so that's it. It has now changed. So my background color now is actually showing that. My background color is actually showing that, which is it is actually exciting. So that's how you can do that. You can often do that for all of them. Text theme, if you want to set the style for your application, maybe the body text style, so you can set it the way you want. Now creating custom themes. Developers can create their own custom themes by extending the theme data class and overriding the desired properties. So custom themes can be used. So okay, let's just look at this. Now if you want to create your own custom theme, as you see here, we can create a class. So I'll just say final my custom theme equal to, we have the theme data. We have the theme data, which is actually what gives the theme, right? So we have theme data. Then inside of my theme data, I have primary color, accent color, text theme. We now define it as what you want. So just copy this code. We are going to define our own theme, so that whenever we want to actually just make changes, we are going to do this. We are just going to use this. So right now I'm going to just create a new file here. I'm just going to call it theme.dat, and I'm just going to paste that here. So I'm going to import the material package, import material.dat, since it all contains this thing. Accent color, okay, this is not defined. I'll remove it. Maybe in the Flutter version I'm going to remove it. Okay, this have been moved on with, so just going to body text 2 is deprecated and shouldn't be used. Use body medium instead. Okay, so body medium. Okay, headline, what are they saying? Headline deprecation, we use display large instead. So display large. Okay, so that's interesting. So that's just how the content are going to be displayed. So this is our custom theme that we have actually created. Now we can now set it in such a way that the theme here should now use, instead it should actually use, what's the name of that theme? My custom theme. That should be it. So I'm going to say my custom theme is going to import the package. If it does not, okay, if it does import UI masterclass theme.dat, if it does not, just import this manually. So how do we import it manually? import, you put your import statement, you go to package, you locate where it should be found, right? You locate UI master class, that's where it's supposed to be found. Okay, then I have theme.dat here, so it's going to come. So I have my custom theme. So now if you come here, this is it. So if I now change this, so realize the benefits of this. Immediately I change this like this. Okay guys, sorry about that. That was a call. Sorry about that. Okay, so we are going to continue. So okay, if you remember, we have defined a theme, right? We have defined a theme. We have colors.purple, and immediately I've changed. What do you see now? This has automatically changed. So now that means this particular one, this particular layout, this particular scaffold, the app bar is always going to take the default theme. That's how now, so everything that we set now, we can just automatically reference this as our theme, such that whenever we want to change a theme, we just come here and change any property of the theme that we want. So that's the theme, my custom theme. We have set it here. So Flutter provides built-in styles and themes for UI elements. The theme class allows customization of styles throughout the application. Custom themes can be created by extending the theme data class and overriding properties. Now let's look at hands-on exercise. Create a new project or use an existing one. Open the main.dat. Replace the existing code with this one. So we're also going to have to create a new one for themes, right? Or in fact, we have seen how to use themes. If you are working alone, go ahead, feel free to use this. Go ahead, feel free to use this. It's good. Okay. So now handling user input and gestures. Handling user input and gestures. Now this is very important. This is very important when it's development. So user input is very important because this is a way you use to actually collect user data from the user, and also handling gestures. For example, this app, let's say if I press this button, how does it recognize that a button has been pressed? Yeah, that is actually a gesture. So Flutter provides a gesture detector widget as a way to build interactive UI elements and handle user input and gestures. So now the gesture detector, now let's say I'm on my screen. I scroll my screen. How does it know that I've scrolled? A gesture detector. So scrolling is a gesture, maybe swiping is a gesture, and all of those things. So the gesture detector widget powered by Flutter has the ability to take into consideration all of this. So the gesture detector widget wraps a child widget and detects various gestures performed by the user. It provides callbacks for different touch events such as tap, swipes, long press, and more. Example code. Now let's look at something. So let's look at something. I'm going to, let's say for example, right, I come to this layouts.dat, and I want to create something that users can be able to click on. Let me shift this. I want to create something that users can be able to click on. So I'm going to come here to the end. I'm going to bring in a gesture detector widget. The gesture detector widget, look at something. We have what they call a child. We have what they call on tap down. We have what they call on tap up. We have what they call on tap. We have what they call on tap cancel, on secondary tap, on scroll, on secondary tap up. We have on double tap, on double tap cancel. We have so many of them. So let's scroll down. We have on long press cancel. We have this is still on long press, on tertiary press. In fact, there are so many of them. On skill start, on this. So what that means is what that means is you can be able to collect gesture from the user at any time. So let me just see on, let's swipe. Okay, this one on pan start, on long press, on tertiary long press. Okay, there's not actually swipe, but there are so many. So there are other packages that can actually give you that. So that's how you use it. So I'll just say on tap. So on tap it should actually on tap, okay, it's supposed to return a function. I'm going to print I'm just going to print tapped. I'm just going to print tab. Then I'm going to actually give now a child, because that is what's supposed to be tab. I'm going to have to give a child. I'm just going to call it a text widget. I'm just going to say tap me. Okay, so that's it, tap me. If I do it, it says here tapped. Tap me again, tapped. Have you seen? So that's how you work with it. So right now I've actually given it the instructions to do that. Touch events callback. Flutter gesture detector provides various callback properties for handling for different touches. Some commonly used we have on tap, on double tap, on long press, on horizontal drag update, on vertical drag N. Okay, have you seen this particular one? Vertical drag N when you draw maybe from one end. All of those, yes, all of those, very important. Let's look at these two. These two can be very important on drag update, even though I've not really been messing out with this a lot. Let me input them. Let me see what happens here. I'm just going to print. I'm going to print dragged. Okay, let me just set it that way. Let me see what is happening here. So I'm just gonna touch it some way like this. It does not actually change too much because the button is a bit too small. Okay, drag. Yes, I swiped over it somehow, and yes, that is it. So I swiped over it because you cannot actually see that, but it actually performed that. If you can see it, dragged. So that's it. You can customize that to your advantage. Gesture recognition system. Now Flutter's gesture recognition system allows users, or let's say allows for more advanced gesture detection and customization. It provides gesture recognizers like the gesture detector. We have the drag gesture recognizer, scale gesture recognizer, and more. Developers can create custom gesture recognizers by extending the gesture recognizer class. Example. So example, we have a gesture detector. We have seen about that. Now the gesture widget allows for building interactive UI elements and handling user inputs and gestures. Flutter provides various touch event callbacks like on tap, on double tap, on long press, and more. So if you want to develop a system, like maybe you want to create something, let's say you want to create a custom button that someone can tap on it and something happens. Someone can maybe long press on it. If you notice it, if you go to WhatsApp, maybe if you want to text someone or you want to delete a chat, what happens? You press on it for a long time, something pops up and you can decide to take action, right? So it's an example code. Okay, this example code is actually interesting. So what we want is just this gesture detector. What we want is just this gesture detector. I'm going to explain to us what it actually does. I'm going to explain what the code does. So this is a piece of code. Okay, I'm going to explain to us what the entire code does. Okay, so I'm going to create a new class here, and I'm going to just call it gesture dot. Okay, so I'm gonna paste that there, and I'm going to correct up all of this style, text style, all of them. We need material app. That's why most of them are undefined. Oh, we just have a child gesture detector. Okay, the first part of it I've not pasted. Okay, so let me remove all of this. Okay, so that's it. So that is actually running. Let's see what this is all about. I just want to show you what it's all about, then I'm gonna explain it. So I'm just going to call this gesture okay, gesture class. So now I'm gonna go to layouts, or no, the main.dat file. I'm just gonna let's see, I go to layouts. Yes, I'm going to call the gesture down here for on my column. So I'm going to call it, since it's a class, so I'm just going to call it gesture. Now let's look at it. Wow, so many things have happened. So I have gotten so many errors. Let me rebuild the application and see what is going on. Wow. Okay, let's try to give an explanation for that. You see, the app has actually crashed. So these are some things you need to avoid. Let's see, the app has actually crashed because the UI could not fit the screen. First of all, okay, it's a scaffold, and a scaffold cannot be in between. Okay, we also have a single child scroll view which cannot be in between content. So I'll go ahead and first of all remove this. Oh no, this is our layout builder. We don't need to change it from here. It's on this. So okay, I'm going to remove this material app. This is the problem. So what I need is just this center to be returned on this particular widget. So I don't need the material app because we already have a material app running. So I'll just paste that and everything should go smoothly now. Yes, everything should go smoothly now. Okay, so you have actually seen here, this one says tap me. Okay, this one says tap me. Let me tap. Wow, you tap the box. Great. So if some of you now, I think you are beginning to enjoy the development, right? Some of you, I think you are beginning to enjoy the development. Okay, now let me explain to us what this code does. First of all, we have our stateless widget which has been created. Now we have our build function, which I think we know what it's all about. Then now we have a gesture detector which has an on tap function. It means when tapped, right? So on tap, what does it do? It shows a dialog. This show dialog is a specific function that Flutter has created to actually do something like a pop-up. So if you notice it, if immediately you press that particular button, it actually pops up something. So it's going to show a dialog. What is a dialog? By Flutter, displays a material dialog above the current content of the app with material entrance and exit animations. Now it has what we call a builder and a context. So it's actually like building a UI component on top of what is already here. It actually suspends it up, so in the form of a dialog. Now if you check, it has a context, it has what we call a builder. The builder now is what builds what comes on top. You can decide to do whatever you want with the builder. Now the builder takes in the context. The context is this page, the context of the page you're actually working with, right? Yes, it actually needs a context, so you should know where to hang on. So if you give it wrong context, it cannot come. So that's why the context is context. And where is the context coming from? It comes from this build context. It means it actually recognizes the UI element it is dealing with. Now it returns what we call an alert dialog. You can, when you, for example, look at this thing here, we have these braces, then we have this opening. So if you want to take away this aspect, you can just use this forward lines. So when you see this, it just means it's returning. So it returns an alert dialog. What is an alert dialog? An alert dialog now is actually the main dialog which is displayed to us as called by Flutter, and it returns an alert dialog which has a title. So look at what happened. This is the alert dialog now that pops up. Show dialog means it actually wants to show to us a dialog, right? So the show dialog creates the environment. Now the builder is what actually builds now the dialog. So the builder now shows an alert dialog with a title which says tapped, with the content which says you tap the box, and it says actions. We have what we call now it says okay, right? Okay. Now when you press okay, what happens is it's going to pop the context. Why? Because we have what we call here a text button. A text button means a button that you can press and something happens. It's like a button, but it's a text. So you can decide to do this many ways. You can either use an elevated button, you can decide to use maybe a gesture detector again there, so that maybe when you touch the text something happens, but we have used a text button. So when you press on OK, immediately this wipes out by using the navigator function. So we have navigator.pop context. So navigator is actually what helps us to navigate between pages, right? So if you want to move from one page to another, the navigator does that. But you can either push context and pop context. So that is on algorithms and data structures. So that's basically the stack layout. So every page, every context lays upon each other in a form of a stack, right? So every page, for example, if you navigate to any page, it creates a stack of itself, like it adds on top of the stack. Anyways, while we are going to be looking at routing, we are going to see about that. So navigator.pop context means it actually just remove the current context on the screen. So okay, it pops this off, right? So that's it. So that's our action. So whenever you see this thing, I think you have seen this thing most of the time. Maybe they want to warn you on something. You see this, you can set it to be not dismissible. Okay, let me say show dialog. Let's see some other parameters. It says barrier dismissible true. That means the dialog can come off screen. But let's say barrier dismissible, I will say false. This is maybe when sometimes when they want to give you a restriction to the app. False. Sometimes you see when I tap outside, it can never go off. It's just I've left this button, but sometimes if I remove this button, if I tap outside, this thing can never go. But look at something. If I remove this particular barrier dismissible, if I remove this, I tap outside, it's going to go off. It's going to go off the screen. It's going to go off the screen. Yes, but in case I leave it there, if I set it to false, it will never go off the screen until I decide to actually type that. Okay, so that is how we work with that. Now let's look at animation and motion. Animation and motion. Now Flutter provides powerful animation framework that allows developers to create smooth and engaging animations in their application, right? So you can often work with animations. Maybe say you want this box to dance. Maybe when the box comes up, you want it to dance a bit. So let's just take a look at the animation framework. Flutter's animation framework is based on the concept of animation as first-class citizens. Wow, impressive. So it provides various classes and APIs to handle animations such as animation, twin, animation controller, and more. So we are going to be looking at how to actually work with all of that. The framework allows developers to define the animation's duration, curve, and other properties. Now let's look at how to create animations with twin and animation controller. The twin class defines the range of values over which an animation should interpolate, right? So the range of values, maybe if you want a particular box that maybe moves around before it stays, yes, so you use a twin to do that. Now we have the animation controller class controls the animation's playback, such as starting, stopping, and reversing. Example, looking at this little code, let's look at, now we have the animation controller. This is what controls the animation, right? How long is it going to be on screen, how it's going to function. So the animation controller is inbuilt with Flutter. So the animation controller is a property that we are going to create an object. So this is actually a class. That's why we call it a class, which has been defined by Flutter. So we need to actually initialize the class. So we are going to give it a name, controller. So the class animation controller, we create an instance of it, and it actually becomes an object. So we have the animation controller. We now give the duration. The duration takes a property called duration, which is a class that Flutter provides. So the duration, you can give it in seconds, you can give it in meetings, you can give it in milliseconds. Then we have what we call vsync. This, you are telling that the animation should sync to whatever you are doing. So always try to enable it as this. Now the animation, so that was actually just the controller. Every animation requires a controller, so that's why this is important. So that's how we define this. So animation, now animation, we are animating a value. So that's why they say animation double. You can have multiple different types of animation. But we want to actually animate a value, right? So let's say the size of this box is actually a double value. It means it's actually a value which can be varied. So it means we can actually control the size by manipulating its value. If we manipulate the value, we can make it in such a way that initially it is big, after it is small. So this is an example. So we have animation double, then we have the animation now, which is equal to twin. So the twin now is as set here. What is the twin? The twin class defines the range of values for which the animation should interpolate. So it should begin at 0.0 and should end at 1, right? So dot animate, then we have controller. Now what does this mean? It's actually going to start at 0 and end as 1. You can actually increase this value to whatever you want, right? Okay, so now that we have seen how to animate, how to create an animation, so we are just going to use this. Let me just copy this code. So we are going to use this animation. So I want to animate okay, let's say I want to animate this particular value, this particular widget, this width. This is a double value, right? I want to animate it. So what does that? It comes on the hello Flutter. So where I have hello Flutter here, I want this particular box, the dimensions to animate when it starts. I want the dimensions to animate. So the first thing is I'm going to go out of this class, like here where I have this. I'm going to define it. Controller can't be accessed in an initializer. So okay, I'm going to put it here. Okay. Anyways, we are going to see about that. We're working on real-time examples. So once a ticker stake timer. Okay, now look at animating widgets with widget builder. So now that we have created an animation, let's just keep this. Now that we have created an animation, Okay, so we need to also set this to let's say a stateful widget. We need to set this to a stateful widget. So I'm going to say convert to stateful widget. Why? Because it is going to animate over time, so it has state. That is what we call a stateful widget. Please, a stateful widget creates two classes. Never, don't put content on this first one, put content on this second one here. If they are not parameters, so just put them here. So say the argument layout state can't be accessed in an initializer. Okay. The reason why it has not been going is because in order to use animation, there is what we need to add specifically to make it work. So we need to add what we call we are going to add with ticker. So we are going to add this single ticker provider state mixing. So this particularly provides a single ticker that is configured to only tick while the current tree is enabled as defined by ticker mode to create the animation controller in a state that all of that. So actually that is all Flutter's work. You can go and read extensively on that, but you need to enable this in order to actually work with your stuff. So now we are going to define our animation controller. We have animation controller, which is animation controller duration 2 seconds. This, then also we have now our animation, which uses the animation controller. Now what do we need to do? How do we use it? We need what we call an animation builder. So I'm going to go ahead and instead put this at the beginning. So I'm going to use what we call an animation builder, animated builder. Okay, an animated builder needs an animation, which we are going to give it animation that we have already created. Then the builder now itself should have now what we actually want to build, right? So it actually requires a context and a widget. So we are going to have our context, context and a widget, sorry. So passing the context, we have context, then we have a child, so it's supposed to take property from a child or whatsoever it is, and we are going to be returning something. So now we have this setup. So now we have to return something. So I'm going to return what I wanted, the hey Flutter box. I wanted a box with hey Flutter to actually be the target. So I'm going to remove it from that position, and we are going to say return it. So I'm going to be returning that stack, right? So I'm going to be returning that stack, and now where we have let's see where we have this width. I'm going to say animation dot value. So let me change the value. So I want the width to be the animated value, so it should end at 20. So also it should begin at 0, it should end at 20. Also I want the height to should be the animation dot value, animation dot value. Okay, so let me see about that. Only hook. Okay, there's an error there. Okay, that's why. Let's see how to put this inside of let me remove it from this row. I think that's the problem. let me remove it from this row and just put it straight. So I wish that's how actually when you're walking it's actually be difficult to walk. Okay, so I just need to put it directly after that welcome. Okay. Now it's a single provider but multiple tickets were created. Mixing can only be used to ticket provider once. Let me restart it. Okay, so since this wants to disturb, we are going to just use a different route for this. So the first thing is we have a stateful widget. We are going to implement what we call an init state. So I'm going to implement init state. So init state should be the initial state, since it has to actually move state. So what I'll first of all do is I'm going to first of all remove this stuff. So I'll define an animation controller for init state. I'm going to define an animation controller, and I'm going to select animation controller. I'm also going to define an animation. So I'm going to say animation. Yes, I'm going to. So animation should actually be of value. So, oh, my phone has gone off. Okay, animation value, we are just going to call it animation. Just going to call it animation, and anyways, let me remove this for now. I'm also going to call it lead. So okay, on the init state now I'm going to define all of this. So where we have controller equal to, we are now going to initialize our controller here. So I'm going to say controller equal to that, then I'm going to delete all of this, and also we define the animation. We define the animation here. Yes, we define the animation here. So we are going to now say that controller dot forward. Yes, so start running this animation forwards here. So it's supposed to continuously tick it going forward. So that will be it. That will be it. So now let's look at our widgets. Animation dot value times, we are going to multiply this. Let's multiply this times 200. Multiply this times 200, so we can actually take the screen. Okay, lead initialization. Let's build. Okay, that is what we want. I believe you have enjoyed that. I believe you have enjoyed that. I believe you have enjoyed that. Let's build it again. So this is how animations take place. So let's see it again, how it happens. Wow, that is beautiful. That is beautiful. That is beautiful. Okay, so that's how we work up with animations. Now let me give a size box so we can actually get some space down here. Height 10. Yes, so that space should not be there. Okay, so we have actually created that animation. Now let's look at where were we even again. Okay, so that was just an application of the animated builder. So if you notice, what have we done here? We have actually just animated the value, right? So we have animated the value of that thing. So it's gonna actually get its value as long as it is running. So it's animating it. It's going to do that for 2 seconds. You can define the way you want it to be. You can actually, you can tune it to, you can do that to any way you want it to be. So now let's look at other forms of animation that we can think of. Now we have physics-based animation, right? Now physics-based animation, Flutter provides physics-based animation APIs that stimulate real-world physics effects. These APIs include twin simulation, spring simulation, friction simulation, and more. Developers can apply physics-based animations to create realistic motion effects. If you notice the way that one was, it was actually some sort of let's say not really smooth, right? You can actually feel the way it's actually heating up itself. But if you want something that is human-like, it's often good to have spring-based animations. So now the only thing that we can do is we can actually just change the controller, right? So let's see how to do this. So if you notice here where we have, let's get the spring animation like this. Let's get the spring animation like this one. I'm going to, here where we have controller, I'm going to no, in fact let me define this here. Spring simulation, Flutter physics. So yeah, spring simulation. Okay, start, not start value. So oops, so we have start, so the start is actually double, so we just see 0, end value we can see 2, velocity is also velocity is a double, so we can see that maybe 5 meters per second. Okay, so that is going to be it. Now for where we have controller, we are going to have okay, so animation is equals to twin this dot animate controller. We have animate controller dot forward. Then also we are going to have now this is how we get the simulation working. So I'm going to say controller dot animate wait, I'm sorry, someone was distracting me. Controller dot animate with simulation, right? Yes, controller dot animate with simulation. That is it, that is going. So okay, so now let's see how that works. Let's see how that works. Okay, let me restart this. Not really changes. I think that was really fast. Let me see the velocity to be 1. Let me see. Okay, you saw how fast it was there. So it actually went on fast. So that's it. So if you pay more attention to that, actually you can do more crazier stuff with the animation. Yeah, you can do crazier stuff with the animation because of this stiff stuff, damping. So it actually makes it like that. So I'm not wasting too much time on that. I think you should always go try ahead. I think there are some modifications you need to do to this code. I noticed this this spring, you're not going to find it here. Sorry, you're not going to find this spring here. So do it this way. Do it this way. The only thing that you need to do is you need to just add this animate with simulation, right? It's gonna go. Now, Flutter's animation framework provides classes and APIs to create smooth animations. The twin class defines a range of values for an animation, while the animation controller controls the animation's playback. Now, the animated builder widget is used to animate child widgets based on animation. Flutter also offers physics-based animation APIs for realistic motion effects. Okay, so you can go about creating some other stuff that you want. Let's look at the clear example. I think there is no need for this one. You can go ahead to do this by yourself, but I think there's no need for this one as we're already working with something else. Now let's take a look at so looking at custom widgets. Custom widgets are widgets that actually developers create, right? While you are working, you can actually create your own widget. So custom widgets allow developers to create reusable UI components in Flutter. They encapsulate a specific set of UI and functionality, making the code more modular and maintainable. So for example, you want to create a very large page, maybe a very nice one. So what do? You definitely just create your different widgets and you actually use them throughout your design. Yes, so we have creating custom widgets. Right now, actually, we have been creating custom widgets. So we actually have the theme, which is okay. No, this one is something else. We have gesture, which actually is a widget, right? So it's actually this is actually a widget which has been created to us. We actually have layout, which actually has its own widgets. Now we can actually use now the gesture widget, whatever we want. Yes, so that's actually how custom widgets work. So creating custom widgets can be created using composition or inheritance. Composition involves combining existing widgets to create a new custom widget. Yes, so you can create multiple other widgets and it forms now to you what is called your widget. For example, this layout widget, right, it's actually it's custom widget which has been created by us. We are actually using other widgets. If you can see here, we have also come right to use the gesture widget that came. Yes, we have also gotten to use it. So that is how they work. So these custom widgets are going to mostly be used when we are working on a project, and I think we are going to be looking at it. So anyways, we are going to see how to mostly apply. So composition, it's achieved by creating a new class that extends the stateless widget or the stateful widget, as you see here exactly, right? So if you see here gesture actually extends the stateless widget. Stateless widget means the state of the object doesn't change over time, whereas stateful widget changes. So example code, so we have class my widget extends stateless widget and maybe it has some information. So this is actually what we call a custom widget. So we have returns a container. So this one is not built by Flutter automatically. You are the one who compose it, and you can use it at any time that you want. Now inheritance involves creating a new widget by extending an existing widget. Interesting. Now it's achieved by creating a new class that extends the stateless widget or stateful widget class and overriding the build method, right? So if you now check class my widget, then now we have the stateless widget. Now we actually have widget build, which takes a context, which returns a container, and now inside of it we actually now have a widget now which we have defined. Now look at something here. What did we return? We simply returned a container, right? Something which is known, something which is actually known. You can just use it inside, but here this particular inheritance, we're actually now using another widget again. So we have used the widget class and we have created another widget which is outside. So anyways, I'll go ahead and just copy this so that we can create it and so you can see how it functions. So I'll copy this. I'm going to create a new widget. I'm just going to call it widget.dat. Yeah, that's good. So okay, need to extend and import the material package. Okay, so this is it. So I can now call my custom widget wherever I want. So since we had a row here, since the reason I like to put it here is because we had a column, and the column now takes in multiple of them, right? So my custom widget, I've called it, and automatically that's imported. So now let me bring this up so that we can actually see how it renders on the screen when I bring it in. So let's take a look. Okay, so we have it there. We have John Doe, who is there. So let's see widget. So it says icons.person. We have John Doe. So it's actually a row widget with children this. So we have actually just do it. So you can now, this is how you work with multiple of them. So this, we are only going to extensively delve into this when actually we are working on real world projects, right? So that's how we are going to actually explore its full content. But as of now, just know that things like this exist. That's how you create. So stateful widget versus stateless. Stateful widgets and stateful widgets maintain states that can change over time, whereas stateless widgets are immutable and don't have internal state. Okay, now stateful widgets are created by extending stateful widget class, overriding the create state method, returning a corresponding state. So that's good. So we have actually seen all of these stateful and stateless widget, so there's no need to really go into that again. So we'll just look at this. So we have really looked into that in depth. Now we want to look at what we call responsive UI design. Responsive UI design. This is a very important and crucial aspect of Flutter, to work with responsive UI design. Why? Because most of the time the components, the UI components you create, right, are not always going to be static. What that means is different users are going to actually be using it. So in order to actually create a good UI component, it must be responsive such that it can be able to automatically scale up and fit other screens when time is when it's required to do so. So you don't actually develop an application where maybe a certain button is only one size on all phones. So there are going to be some that are going to look awkward. Yes, so that's how you can do it. So you need to be able to take the shape. So responsive UI design in Flutter allows applications to adapt and adjust their layout based on different screen sizes and orientations. So handling screen sizes and orientations. So let's look at this. Now Flutter provides the media query class to obtain information about the device's screen size and orientation. The media query class can be used to make the layout decisions based on the available screen space. Now we actually use what we call media query data, right? So media query data, we have in media query data. Remember, this is how we create a class. So this is a class which is provided to us by Flutter, media query data. Then we name it, then it's equal to media query dot of context. So media query is actually now taking the query of the media. So it's just in a way that Flutter uses to actually collect the specifications of the device to which this is running with. So it's media query dot of context where this particular widget is actually being rendered. So that we have double screen width equal to media query data dot size dot width. We have the double screen height is equal to media query data. So the media query data is this dot size dot height. So you can use it in any way that you want. So let me show an example. So now where we had let's say this particular box which we had to animate in this form. Let's say this particular box which we had to animate in this form. What am I going to say? I'm going to here where we have the build method, I'm going to define width. I'm going to define the width. I'm just going to say a double width equal to media query dot of context of this particular screen dot size dot width, right? So that's it. So I'm going to do this too for height, or let me see, I just wanted to I just wanted to actually work with width, so now I'm just going to say multiplied by the width. So width, so now the width should be multiplied, or let's say the, okay, let me just animate only the height is animated. The width, I'll just put it to be the width. Okay, the width that we have designed. Now let's take a look at and review this widget. So if you have seen now, it says the width is equal to width. So what that means now is it's actually just taking the entire width of the screen, right? So that's why, so no matter what happens now to this screen, even if I tighten it smaller, what happens, you can see how it always fits up to the requirements. That's how wonderful it is. That's how wonderful it is to work with a media query. So it doesn't matter the device now which is working here. If you bring an iPhone, you bring a laptop, whatsoever it is, you are going to have the same display. Why? Because it's going to automatically fit the screen. I don't know what's happening here. Wow, this wants to disturb me. Okay, so that's it. Now let me multiply this by 0.5. So if I multiply it by 0.5, it's like I'm dividing it by 2, right? So it's gonna be half. So you see half, maybe I get it now to 0.8. So what that means is every time it's gonna render with this specification. So it's very important, very important. So let me review the app. Let me see how the little animation is gonna work. Okay, so you just saw the way that I just did this. We don't have really time to really look in depth into all of that, but it's just the overview. Now the orientation builder widget can be used to handle changes in device orientation and adjust the UI accordingly. So provided that maybe you are on landscape, you're on this, you can actually change. Yes, so okay, let's just see something. Let's just see orientation builder. Let's just get this particular widget here. I'm just going to see I'm just going to create orientation that so I'll be able to access it. Return the material app. Okay, it's supposed to be a widget. Orientation. So I'm creating a reusable widget orientation. I'm going to put it like this. No, then now I'm going to return it. No, return orientation builder. Okay. The widget start with a capital. Okay, good. We have created a custom widget which is supposed to be orientation builder. So if you notice it takes into account a build context and an orientation. This orientation is the orientation of your screen. So automatically it's going to say current orientation is, and it's going to print it. So let's use this function. I'm just going to call the orientation function in this method. So I'm just going to say orientation. So I'm just going to call the orientation here and bring this up. So let's see the name of the orientation it actually gives to us now. It's a current orientation.portrait. So have you seen? So it's portrait. It means my device is actually on portrait mode right now. So I can always decide to change that. So I think now you've actually understood now how that is. So if you want, you can now decide now that this is how you work. If if you want to actually now set it in such a way that maybe maybe you want to change the display of your UI based on the orientation, right? So you can now say that if orientation is equal to portrait, you display something else, else not, you display something else. So I don't really know how I'm going to explain that. Let me just see something. Okay, okay, I'm just going to say this. I want to actually create something here which is a bit dynamic. I'm going to be using the ternary operator. So I'm going to say orientation equal to I'm going to say orient. Okay, orientation is equal to orientation. Let me give you the same name, orientation dot portrait. I'm going to call a ternary operator like that. You should print text. Current orientation should be equals to, let me just put portrait. So that's a ternary operator. Or if not, if it's not actually portrait, I'm going to now print text error. So let's just see what that is. It says error, it means orientation. The orientation is not portrait according to it. Okay, now let me use triple equal to here. No, it says the type of right hand string is not a subtype of the left side. Okay, let me see something. Okay, this is it now. Yes, so orientation dot portrait. Okay, yes, let's see now this. Okay, current orientation portrait, but if not, let me actually take time to do this so that we can actually see maybe how it bends. So I'll change orientation on my phone. Current orientation portrait. No, it's not supposed to be so. Let me rebuild this. Okay, I think it's quite a little bit of mix up there. Perhaps I don't really know what that's doing like that. I don't really know why that's doing like that. If orientation equal to orientation dot, anyways, that's how we do it. I don't really know why it's not getting the appropriate way that we want it to be, but that's how we get on its orientation. Okay, let's see what the way the phone actually sees it. Now we set the original style that was here was for it to print the original orientation, right? So let's just set it back to that way. We're just gonna print the original orientation for us and not tune it. So orientation.portrait. Now let me see what is going to happen. Orientation.portrait still says orientation.portrait. So it means it's not actually being orientated very well. So it means the app has not actually been orientated, so we actually need to change it. Anyways, let it be. We are going to see how to work with that in the future. Right now, let's just concentrate on what we are doing. Okay, so we have implementing adaptive UIs. Now Flutter provides a layout builder widget to create adaptive UIs that respond to changes in the available space. The layout builder widget allows developers to define different layouts based on their available constraints. Now look at what the layout builder does. Very powerful, right? Layout builder context constraints. If constraint.max width greater than 600, it should return desktop layout, else it should return mobile layout. Now this is the case where you are working with maybe different screen sizes, or let's say for example the applications which display differently on the web and display differently on your mobile phone, right? Like Facebook, if you open Facebook on the web, it displays differently. So this is now an example of what we call the mobile layout and the desktop layout. So how do you check this? You check this based on constraints. So as you have seen here, if the constraints are greater than 600, that means the screen is actually larger than 600. What happens is you return to use something else, whereas if it is actually lesser than, you should return something else. So that's how you work with it. Now also we can use this in the form of media query. So get the media query data, and screen width should be equal to media query data dot size dot width. So if screen width is greater than 600, it should render the desktop UI. So these particular ones are widgets that you can set up by yourself, right? So depending on how you set them up, you can always use them, utilize them efficiently. Now let's check at the summary. Responsive UI design in Flutter allows applications to adapt to different screen sizes and orientations. So the media query class provides information about the device's screen size and orientation. The orientation builder widget can be used to handle changes in device orientation. The layout builder widget allows for the creation of adaptive UIs based on available constraints. So this is an example. Basically, let me see. So we have, okay, the constraints. Okay, so this is it. So they have defined the mobile layout and the desktop layout. Okay, let's just look at this. And how it functions exactly. So in fact, let me just explain the code. Now we have the widget build, takes this. We have the body, which is a layout builder, and it has a desktop layout, and it actually has the mobile layout. Let me see. Okay, so I'll just call these constraints dot. So put this here, and I'm going to call on my material app. So I'm going to render that. So I'm going to call it I'm going to call on the my app function as a class. So let me just call it here on this. So I'm just going to call my app. So that's just going to be the base widget that is just going to render. I don't want this other one to render again. Mobile layout, you see, because we are using a mobile screen. Let me remove that. Let me remove material app widget. Let me remove this material app widget. I'll just leave on with this scaffold. Okay, so this is mobile layout. So provided I was on a screen larger, I'm going to definitely see that desktop layout. I don't know if maybe if I can get that done here, if it's possible. Let me see. Oh, desktop layout, that's it. So that's it. So automatically you can see how it actually updates on real time. You can see how it updates on real time. Mobile layout. So that's how we work with responsive design. So I hope that has met you well. Now, okay, this is one of the topics I think it gets this course exciting, which is state management. Now, state management is actually one of the most important aspects when it comes to development. But if you are just coming new, you don't need to necessarily use state management. So this is only for those who actually want to advance their course, right? So you can see it's a bit long. So so state management is a way for your application to actually preserve state, right? So while you are doing your application, we have seen the aspect of state. So your application needs to have a way of preserving state, for example, whereby you can actually control the state of your application via some other technicality that you define. So state management is an essential concept in Flutter that involves managing and updating the data and state of an application. So state management concepts that you should know about. So state management is crucial to keep the UI in sync with the underlying data and handle user interactions effectively. It helps in separating the UI from the business logic and facilitates code organization and reusability. So popular state management solutions. Let me give you an example now. Here where we had this team, right? We had this team which was actually here. And in order to, this team was just a variable. So this variable here can actually be accessed throughout this application. In fact, that variable there is called what we call a global variable. So what that means is it can be accessed by all classes and objects within our application. So sometimes there are variables that you want to expose throughout your application that all classes should be able to handle. For example, if a user logs into an application, you want to make the information on that user publicly visible to that application, so that you can be able to use the user's identity wherever you want within the application, right? So that's actually very important when dealing with development as a whole. But in as much as you want to actually display this information or make it available, you definitely not want to compromise on security factors. For example, if you deal with an application that exposes user data, you might be a victim of injection, SQL injection, and others vulnerability threats. So what that means is you need to have a way of securely passing in these global variables of some sort. That's just an example, over a channel whereby even though they are exposed, but they are protected. Yes, that's what state management comes into play. You can hide data, you can protect data, you can preserve data via using this. Let's say you are dealing in an application that you use a cart. You go to an e-commerce application. The moment you click on add to cart, automatically you see up there one cart item has added, price updated, and everything. How does this take place? You need a state management tool in order to do that. Yes, something that can keep the data and can be able, you can now use it via your entire application without actually having to really go everywhere. So it's like this variable, just imagine we go to each class, we define it inside, it's not going to be good. Yes, so that's why we need state management tools. So Flutter has many of them. The first one is Provider. Provider is widely used state management solution in Flutter that uses the inherited widget mechanism to propagate UI changes to the UI. So as I've spoken to you about cards, and as I've also spoken about other things, so there are many of them. It allows for dependency injection. This is actually very important because sometimes you want to maybe pass in information. It's really, in fact, we are going to be dealing with real life applications, like, okay, for example, we are going to be dealing with databases. We are going to be needing state management a lot in order to actually share information within our application via secured means. Yes, so for example, a page, you want your home page to know data, maybe that can be coming from a page which is right inside of the application on a different widget tree. So how do you do this? You need state management. So we are not actually going to see much of these other ones. Some of them are simpler, some of them are not simple, but I will not want to really go ahead. You can try all of these examples. What we are going to be using is Riverpod. Yes, Riverpod, because all of my coding exercises you are going to be using it, but there are many of them. You have seen Mobex, you have seen okay, you see things like block. So all of them are actually available, but we are going to be using Riverpod. Yes, Riverpod, Flutter Riverpod. Now, Riverpod is an improvement over Provider and offers a more modern and robust state management solution. It provides a declarative syntax and leverages the concept of providers to manage state. So actually you collect information or the state of an application. Maybe you want it to be able to update. So what happens is you collect it and you provide a declarative structure such that you can be able to modify it or use it wherever you want, right? So throughout your solution, you can now use what they call a provider to actually provide it to wherever it is required. So now we have an example. Final counter value should be equals to provider, which provides an integer, and it's actually the value is 0. Now now look at, we have final counter is equal to watch counter provider, return text counter. Now let me explain this code to us properly. Counter provider is actually providing to you a certain value for counter. Let's say if you are having an application like the initial application that we had, whereby the moment you press on a button, what happens? It increments, it counts. So what do you want to do? We want to set it in such a way that the value that counter holds should be changeable and we should be able to control it, but we do not want it to be exposed in such a way that every feature of the application can change it. Least there are going to be errors within the application because sometimes it might be mismanaged, right? So we need to enable it in such a way that we can handle it such that the entire application, we can have access to the information provided by that counter. Let's say if you are dealing with an application that maybe you have to play a game, and at the end of the day that particular application needs to return to you the total, or it needs to be showing you the current value of the user. How do you deal with that? Use what they call a state management tool like provider. So I'll say final counter provider should be equals to provider is supposed to provide an integer. That's what this, you see this here embraces. If it was a double, it can provide. So the provider now takes in what they call ref, and it should return 0. So that's the initial count. Right? Whenever it initializes. Now, if you now notice, we have now class my widget extends consumer widget. Consumer widget now is a widget that can now read data from your state provider, from your state management tool. So now this is a winner of this particular widget being able to read that particular provider without actually interfering with it on let me say on negative basis. So for example, we have our consumer widget. Now we have what we call a widget build, we have a scope reader watch, or if not this, we can just use ref. So now we have final counter is equal to watch counter provider, then we have a text which is equal to a counter. So I just want to give an example. Now we are going to create a little button, or let's say we are going to create a little let's see, we are just going to create a little button down in our application that every time you press it, the value increments by 10. The value increments by 10. So we are going to be using the provider to do that. So where we have these constraints, I'm just gonna edit this constraint screen. So I'm going to come up here and so where we have a layout builder, since I'm on a UI, I'm just going to update the mobile layout. So this, first of all, let it return let me first of all define my provider. So I'm going to go to another class. I'm just going to define my provider there, I'm going to say that I'm going to say count provider. So it's just going to be something like a game. So count provider dot that. So I'm just going to say now that final count is equal to provide. Okay, I've not installed Riverport. Okay, now Riverport is a package, right? So how do I install Riverport inside of my application? I'm going to go to the package repository. I'm going to go on to pop.dev. That's how we call it. Pop.dev is a repository where you can find Flutter packages. So I'm going to go to pop.dev and I'm going to search for Riverport. So it's a package that you can find here. Look for Flutter Riverport. So I'm going to now go for installation. I'm going to let me see, installation. I'm going to copy this command, flutter pop add. So this flutter pop command is responsible. It's going to now install Riverport inside of your application. So I'll put that. Make sure you have internet connection to do this. So I'm going to add now Riverport. Okay, so Riverport has now been added into my application. So now I can be able now to use Riverport via my entire application. So let me wait for it to analyze. So now I'm going to call for provider. It's not still initialized properly, so it's still doing its work. Let's just give it some small time. So I'm going to call on provider. Okay, so provider is available now. So I'm going to call for provider, and we have what we call 0 that I'm going to give to it. So this is my provider. That is all what it keeps. That is all what the provider keeps. So it just contains that initial information. And now I'm going to need to control it. So now I'm going to this thing. I'm going to remove this thing from this way that it is. Okay, mobile layout. Let me see if I can put this in a column. Okay, let me put it in a column. Let that one be there like that. Mobile layout. Okay, so right down here now I'm going to put text. I'm going to put the text. Okay, firstly remember that we want to be able to read the content of that particular provider. So now, since we are using Riverport, we are no longer going to be using the stateless widget. We now need to do what we now need to use what we call a consumer widget. So I'm going to say consumer widget. So we have a consumer widget, and we have a consumer stateless widget. So we have a consumer widget, then we have a consumer stateful widget. This is a stateful widget, whereas this is just a state widget. So I'm going to have the consumer widget. So this is the widget now provided by Riverport that is going to enable us to read the state. So it takes in the context, and it takes in what they call a widget ref. So we have a widget ref. So remember when we're declaring this counter, we had what we call provider, which required a ref here, which is actually like a reference if you just put it that way. So we have a widget ref. So now I have now this. So now I'm going to have now a text here. I'm going to have now a text now here. I'm going to have a text widget down here. A text widget. The text widget should actually return to me the value of that counter. So the text widget is going to be ref dot watch. Watch means it constantly checks that value and returns it to you. We have ref.read. Ref.read means it's just going to read it to you and give you, but it's not going to be able to update over time. But ref.watch means that it's going to constantly read it and update your UI based on it. So I'm going to say ref.watch. I'm now going to call counter provider. So counts, okay, that was counts, yes. So this is count here. I'm just going to call count ref.watch count. It says can't be accessed in the parameter provider listing string. Ref.watch. Let me see what is happening here. So count is final. This is supposed to be provider. Final provider. What are they saying? Okay. Now I get something. The first thing that I need to understand is whenever you want to use this provider, the first thing you need to do is you need to enclose your material app into what we call provider scope. You need to put your material app inside of it. A provider scope is going to initialize provider all over your application such that your entire application can communicate with the provider. Remember, the difference between providers now and global variables is that even though they seem to be global, they are immutable. Yes, okay, this one cannot change. I'm going to close and rebuild our entire application again. I think that's why we have an error. So let's wait for it to just run very fast again. Since we have included provider scope, it must definitely be given. Okay, so our app now is ready to listing from provider. Okay, provider dynamic is not a subtype of this. Okay, so now what we want is this is actually okay provider. So what we actually want is this particular provider is going to be changing state. So this cannot just be a provider. We're going to be using the state notifier provider. So I'm going to show you how that is being used. Okay, looking at very well. Okay, let's set this to an integer. So this we have a provider of an int. I'm not going to use a state provider. I'm going to use this. So I'm going to come now. The problem here is we actually have this actually returns an integer, and what we want is a string. So I'm going to be using .toString. .toString is going to actually convert our output into a string, right? So this actually was returning an integer, but we're actually going to give it a string. So now you can actually see a 0. Then I'm going to put here plus I'm going to say points. So 0 points plus yes, plus that. So I'm going to have 0 point. Why does it not give space? is interpolation, replace with interpolation. So okay, we have 0 points now. Okay, so now I need to implement the logic that will be able to update this UI. So I'm going to have an elevated button. On pressed is going to, we are going to have ref dot read. This one is just going to be reading ref dot read count plus plus. No, it's the child here. We should have a text which says increment. Okay, this is illegal assignment of non-operatable assignment. Okay, so ref.read count. Okay, I will just say that. Okay, so let's see how to debug this. Okay, implementation of provider is actually does not actually give us directly the ability to actually update the UI, so we need to implement that. So what we can do in order to implement this is actually working with our provider. So now let's see, we are going to create a class. So I want to implement the function that is going to have all of those things. So I'll create a class called count notifier. You can call this anything you want. So I'm going to actually extend our state notifier. I'm going to extend our state notifier. So this I'm going to have what we call a count notifier. I'm going to call the count notifier. I'm going to be calling its constructor, and I'm going to be giving it what we call a super, and I'm going to pass it 0. So what have I done is I've actually initialize it to 0. This is how you give it a state notifier, like if you want to actually do a change notifier. So I'm going to now get the function to increment. So I'm going to say void increment. So I'm going to say that I'm going to now change the state. So I'm going to say state plus plus. So I've actually incremented the state now. I'm going to say void decrement. I'm going to say state minus minus minus. Okay, so I've actually created it. Now what I need to do is I need to actually do my provider. I need to actually provide it. Oh, this decrement should only work if it's actually less than 0. So if actually greater than 0, sorry. So if state greater than 0, I'll now say state minus minus. Okay, that's good. Okay, now I need to I'll now say final count should be equal to state notifier provider, which now takes in my count notifier as a provider. That's good. So we have actually implemented that. Let me see something here. Okay, so let's see constraints, increment, we have ref the read count. No, so now where we have here, so I'm going to have ref dot read count, then I'm going to put now dot notifier. So what that means is I'm accessing the notifiers. So I'm now going to say that count, I'm just going to say new count is equal to ref dot read. So I'm going to just say var, let me just call it var. So var new count should be equal to that. Then I'm going to say that new count dot increment. So I'm going to be incrementing, so I'm actually now handling that data. So let me refresh this application. Whenever you refresh your application, your provider changes, so I'm going to be refreshing it. So it has actually changed. So let me see, increment 1 2 3 4 5. So that's actually how it is now. So I'm actually now using provider to actually get the value of my provider. So if you can notice it, this is acting now like a global variable. So what is happening is I'm using another class to manage the content of this class. So this is actually like it's virtual, right? So this is actually like it's virtual, and I'm actually accessing the data. I can manipulate it and I can control it. So depending on what I want to actually define or what my objective, I can always model this to actually fit that particular scenario. Yes, so we have the state notifier, we also actually have the provider, we also have change notifier. So you can always do it. So state notifier notifies the state, updates the state. So you can use the state notifier to actually have so many things done. You can also use provider directly if you're actually providing UI components, right? Yes, so that's how you do it. So you use the widget ref, provider ref, to actually do that. Now since we have looked at this, we are not going to really go in depth into the other ones. As I said, we are not going to look at all of these other ones, but you can go ahead and try them with the examples. So we also have what we call block. So block is a state management pattern that separates the business logic from the UI. It uses streams to handle data flow and provides a clear separation of consent. So block is actually interesting. Block is actually interesting. Block is actually a method that we can use to actually handle, we can use it to handle streams of data. For example, if you have built an application that actually is able to, let's say, do a search, or let's say you go to some of applications, let's say for example Facebook, and you go to the search portal, you search for a certain post, and you see it's able to search and return to you result. What's happening? So what's happening is that your application has the ability to fetch all of this information and return it to you. So block is a very good solution to that. So right now, since we are just working with UI, we cannot really understand the applications of block. But anyways, I think in due time, while we are going to be advancing, we are going to be getting deeper into it all. We are going to actually see now what block does. So let me see if this example code, let me see what this example code is. Okay, now let's try to implement this example code and actually have to see what block is all about. So I'm going to copy this. I'll just copy it all like that. So I'm just going to see block dot that. So I'm going to see block dot that. I'm going to paste it. I'm going to import these things, material. Then I need to locate where I have this data, my personal data, and remove it. Okay, so